Okay, last example in this section. We've got this integral here, and it's integral from 0 to 4 of 1 over x minus 2 dx. And there's a warning here. Don't miss the fact that this is an improper integral. If you just took this and said, oh, this is going to be ln of x minus 2 from 0 to 4, you can plug those numbers in and you get the wrong answer. So don't do that. You need to catch that this is improper because in between 0 and 4 is the number 2. And this function here, 1 over x minus 2, has a vertical asymptote at 2. If you were to graph this, it would look like this. So 1 over x minus 2. If we're doing this from 0 to 4, we've got this big vertical asymptote here in the middle. So what we have to do is rewrite this as integral from 0 to 2 of 1 over x minus 2 plus integral from 2 to 4 of 1 over x minus 2. And then we have to do these individually. So let's do this one first. I'm going to rewrite it as the limit as t goes to 2 on the positive side from 0 to t of 1 over x minus 2 dx. And now we can do the integral. Integral of this is going to be, I'm going to skip a little space, the integral of that is going to be ln of x minus 2 in absolute values from 0 to t. And of course that's with the limit going as t approaches 2 from the positive side. Now let's plug the t and the 0 in. So we've still got the limit as t goes to 2 from the positive side. So we've got ln of t minus 2 minus ln of 0 minus 2. And so let's see, those absolute values are there. So as t goes to 2 from the positive side, this is going to approach 0. And so natural log of 0 goes to negative infinity. You know, the graph of natural log of x looks like this. And if we're approaching 0, we're coming down here and going to negative infinity. So it looks like we get negative infinity minus ln of 2. But this negative infinity here tells us that this diverges. And we don't even have to do the other integral. That's enough for us to say this thing diverges. If we did do the other integral, let's look at Desmos and see what's going on. So basically, we're looking at f of x equals this. And we're restricting ourselves to 0 to 4. 0 less than or equal to x, less than or equal to 4. So it's like we're trying to find the area between those two things and the x-axis. So let's so basically the integral that we found just now was from 0 to 2. I'm going to copy this. It'll let me. So if we just look from 0 to 2, and let's see, that's the stuff that's between 0. So y is less than or greater than or equal to that. So basically, that's the area that we found when we did the integral from 0 to 2. We found that area, and that area came up as negative infinity. Negative because it's below the axis, and infinity because it's an infinitely large region. So that's enough to tell us this thing diverges. Now, if we did the other integral, what we would get out of it would be positive infinity, because that would be the area over underneath here. And you can't add positive and negative infinity together and have them cancel out and it not be divergent. As soon as you get that positive infinity for one of these things, the thing is divergent, and that's the end of the problem. So that finishes up this section.